Hello there, curious minds. Today, we are diving into the life and legacy of a man whose work allows us to literally see through the human body, Wilhelm Conrad Röntgen. This portrait introduces us to the visionary who received the very first Nobel Prize in physics in 1901. Born in 1845, Röntgen wasn't just a scientist. He was the pioneer who bridged the gap between abstract physics and life-saving medicine. Imagine the world before X-rays. Doctors had to guess what was happening inside a patient's body. Röntgen changed all of that with a single accidental discovery that we are about to explore together. Get ready to be inspired by a story of curiosity and profound impact. Before we continue, dear friends, don't forget to subscribe, like, share the video with your friends, and also leave comments to encourage us to continue making this kind of content. Before we get into the science of X-rays, let's understand the prestigious context of the Nobel Prize. Look at this beautiful diagram. The Nobel Prize was founded by Alfred Nobel, a Swedish inventor and philanthropist. He wanted his immense wealth to celebrate those who confer the greatest benefit to humankind. Think about that for a second. The goal isn't just to be smart, but to use that intelligence to help everyone. The prize covers 5 original categories: physics, chemistry, medicine, literature, and peace. Each field represents a pillar of human progress. Alfred Nobel's legacy reminds us that true success is measured by how much we improve the lives of others. Isn't that a motivating thought to start our journey? Now, let's zoom in on the Nobel Prize in Physics, established in 1901. This timeline highlights some of the most earth-shaking discoveries in history. We start in 1901 with Wilhelm Conrad Röntgen and his X-rays. Just 2 years later, in 1903, the Curies and Henri Becquerel were recognized for their work on radioactivity. Then, jumping to 1921, we see the legendary Albert Einstein rewarded for explaining the photoelectric effect. Why are these grouped together? Because they represent a radical shift in how we understand the physical world. These scientists didn't just find new facts, they redefined the boundaries of reality. When you study physics, you aren't just memorizing formulas, you're following in the footsteps of giants who changed our understanding of the universe. Let's trace the map of Röntgen's life to see how a student becomes a legend. 1. It began in Lennep, Prussia, now Germany, in 1845. He then traveled to Switzerland to study engineering at ETH Zurich. This is a crucial detail. His engineering background gave him a unique perspective on experimental physics. He knew how to build and manipulate complex tools. 3. The magic happened at the University of Würzburg, where he taught and eventually made his world-changing discovery in 1895. Finally, he passed away in Munich in 1923. Notice how his path wasn't a straight line. He pivoted from engineering to physics. This shows us that your education is a foundation that can lead you to unexpected and amazing places if you stay curious. Before we continue, dear friends, don't forget to subscribe, like, share the video with your friends, and also leave comments to encourage us to continue making this kind of content. This is it, the moment of discovery. Let's break down this experiment step by step. Step 1, the setup. In November 1895, Röntgen was working with a cathode ray tube. This is a vacuum tube where electrons are fired from one end to the other. Step 2, the anomaly. He covered the tube with thick black cardboard to block all visible light. Suddenly, he noticed a screen across the room, coated in barium platinocyanide, started glowing, fluorescing. He realized that some kind of invisible ray was passing through the cardboard and hitting the screen. Step 3. The conclusion. He had found a form of radiation that could pierce through materials opaque to normal light. He named them X-rays because X is the mathematical symbol for the unknown. He didn't know what they were yet, but he knew they were revolutionary. This is the scientific method in action. Observe something weird, investigate it, and draw a conclusion. Behold, the most famous scientific photograph in history. Just weeks after his discovery, Röntgen took this image of his wife Bertha's hand. Look at the two images side by side. On the left is a normal photo. On the right is the X-ray. Look at what it revealed. The radiation passed right through the soft flesh, but was blocked by the dense bones and the metal wedding ring. When Bertha saw it, she reportedly exclaimed, "I have seen my death," because seeing one's own skeleton was so shocking at the time. But for the medical community, this was a miracle. For the first time ever, humans could see inside a living person without surgery. This single image instantly launched a new era of medicine. Why was this discovery worth a Nobel Prize? Let's look at the physics of the opacity matrix. 1. High penetration. Materials like skin, muscles, and soft tissues allow X-rays to pass through easily. These appear as dark areas on the film because the radiation hits the film behind them. 2. High absorption. Dense structures like bones and certain metals like bullets or jewelry absorb the radiation. They block the rays, leaving bright white shadows on the film. The medical reality here is profound. Doctors could now locate fractures, see swallowed objects, or find embedded bullets without making a single incision. It transformed surgery from a guessing game into a precise science. It's all about the interaction between energy and matter. X-rays aren't just for broken bones. Look at how this one discovery penetrated every major scientific discipline. 1. Medical radiology, from simple X-rays to modern CT scans. 2. Dentistry, checking for cavities and root health. 3. Industrial imaging. Engineers use X-rays to check for cracks in airplane wings or pipelines without taking them apart, non-destructive testing. 4. Security screening. Think about airport luggage scanners. That's Röntgen's legacy keeping us safe. 5. Scientific research. Scientists use X-rays to look at the very atoms that make up crystals. It's amazing how one discovery in a small lab in 1895 now touches almost every aspect of our modern lives. Before we continue, dear friends, don't forget to subscribe, like, share the video with your friends, and also leave comments to encourage us to continue making this kind of content. Röntgen's legacy is like a tree with many branches. Let's explore them. 1. Modern radiology, the bedrock of hospital diagnostics. 2. X-ray crystallography. This is incredible. This technology was used decades later by Rosalind Franklin to capture the images that allowed Watson and Crick to discover the double helix structure of DNA. 3. The Röntgen unit. For a long time, his name was the official unit used to measure radiation exposure. 4. X-ray astronomy. Because some stars and black holes emit X-rays, astrophysicists use X-ray telescopes to study the most violent and energetic parts of our universe. One observation in 1895 literally opened up the entire cosmos for us to see. Röntgen wasn't just a great scientist. He was a man of incredible character. Here are 3 facts that should inspire us all. 1. He refused to patent his discovery. He believed that X-rays belonged to all of humanity and should be available to everyone without cost or monopoly. 2. He was a generous laureate. He donated his Nobel Prize money back to his university to fund future scientific research. 3. Because he didn't patent it, hospitals worldwide adopted the technology in mere weeks. This is a powerful lesson for us. The greatest benefit to humankind often comes when we prioritize progress over profit. Röntgen didn't just want to be famous, he wanted to be useful. To wrap up our journey, let's look at this beautiful prism and Röntgen's own words. I didn't think, I investigated. This is the heart of science. It's about curiosity, rigor, and the courage to look at the unknown. By illuminating the invisible, Röntgen gave humanity the power to heal without harming. His legacy beats at the heart of every hospital and laboratory today. Remember, students, great discoveries often start with a simple, "That's strange," and the determination to find out why. I hope Röntgen's story motivates you to keep investigating the world around you. Who knows? Maybe the next world-changing discovery is waiting for you to see it.